Imagine taking any picture you can think of, a painting, a cartoon, maybe even an old black and white photograph, and then having a real-time conversation with it. For hours. Yeah, this isn't sci-fi anymore. Today, we're going to break down a brand new AI called Live Avatar, and trust me, it's a technology that really changes the game.
So just look at this character for a second. What if you could actually talk to him? I don't mean some pre-recorded animation. I mean live, responding to your voice for as long as you wanted to chat. The researchers who built this had this perfect motto, make the fire talk. And well, as we're about to see, that is exactly what they have done.
All right, here's our game plan. First, we're going to talk about the dream of having truly live avatars. Then we'll get into the two massive hurdles that have been holding this tech back for years. After that, we'll unpack the 3 key innovations that Live Avatar uses to solve the puzzle, see how it performs against the competition, and then wrap up with why this changes, well, pretty much everything.
So, let's start with the big picture, right? The ultimate goal here, the dream, has always been to generate a totally realistic talking character that is animated only by a stream of audio. No fancy motion capture, no huge team of animators, just a voice and a single solitary image.
The fancy term for this is audio-driven avatar generation, and it's the engine that's going to power everything from the next generation of virtual assistants and live streamers to truly interactive characters in video games and VR. I mean, the potential is just massive, but it's always been held back by some really fundamental challenges.
And that brings us right to the heart of the problem. For years, AI researchers have been stuck in this really frustrating spot, trying to juggle 3 things: speed, quality, and stamina. You could get a high-quality avatar, or you could get a fast one, but you could never ever get both. And even then, it couldn't keep going for very long.
Let's break those 2 big hurdles down. First up, you've got the speed problem. See, generating high-quality video is just incredibly demanding. Think of it this way. A beautiful, detailed oil painting takes a ton of time to create, right? But a quick pencil sketch is fast. It just lacks all that detail. AI has always faced that same trade-off. Then you have the stamina problem. Over time, these AI avatars would literally forget what they were supposed to look like. It's a phenomenon called identity drift. And the best analogy is making a photocopy of a photocopy. Each new copy gets a little bit blurrier, a little more distorted, until it's just a mess.
And this is where Live Avatar enters the picture. It's a system that was built from the ground up, specifically designed to solve this dilemma. This isn't just some small tweak or a minor improvement. It's a completely new way of thinking about the entire problem.
So Live Avatar solution is this brilliant 3-part punch. First, they use something called causal adaptation to make the AI ready for live streaming. Second, they've got this wild assembly line approach to make it unbelievably fast. They call it TPP. And third, there's this clever memory trick called RSFM that completely solves that identity drift problem. So let's look at how each of these actually works.
Okay, first up, causal adaptation. The idea here is actually simple but so powerful. They take a massive, slow, but absolutely brilliant AI model. Think of it as the teacher, and they use it to train a much smaller, faster student model. This student learns to create the exact same high-quality video, but it can do it frame by frame, which is absolutely crucial if you want a smooth, real-time video stream.
Next, let's talk about TPP, because this is how they cracked the speed problem. The old way was like one person trying to build a whole car by themselves. It's slow. TPP, on the other hand, creates this hyper-efficient assembly line using multiple GPUs. GPU number 1 handles step 1, passes the result off to GPU number 2, and then immediately starts working on the next frame. You get this continuous flow, and the result is that it's pumping out frames at over 20 per second. That's more than enough for silky smooth, real-time video. This isn't just a number, it's the difference between a laggy mess and a seamless, magical experience.
So, finally, how do they fix that stamina problem, that photocopy of a photocopy issue? They use something called the rolling sync frame mechanism. And this is just a fantastic trick. The AI is programmed to periodically just glance back at the original, high-quality reference image. This little peek resets its memory, making sure it never drifts too far from how it's supposed to look. It's just like the photocopier taking a look at the original document every few copies to make sure it's still sharp. Genius.
Okay, so the theory sounds amazing, right? But does it actually work? Now we get to the fun part, the proof. The research team put Live Avatar through its paces, testing it against all the other top models out there to see how it really stacks up.
Now, what's really fascinating about this slide is the speed. Just look at the first two columns, image quality and lip sync. Live Avatar is right there with the best of them, totally competitive. But then you look at that last column, speed, measured in frames per second. The other models are chugging along at less than 1 frame per second. Live Avatar is hitting almost 21. That's not just an improvement, that is a whole different league. It's revolutionary.
And what about that stamina issue? Well, this graph is all the proof you need. See that turquoise line for Live Avatar? It's almost perfectly flat, meaning the quality is high and it's rock solid over time. Now look at the purple line for another top model, Omni Avatar. It holds on for a little while, and then bam, the quality completely falls off a cliff. The takeaway here is crystal clear. While the other models just fade away, Live Avatar holds strong.
And this slide right here shows you exactly what that graph means in the real world. On the left, that's Omni Avatar after about 6.5 minutes. The image is distorted, it's blurry, it's that identity drift we were talking about in the flesh. On the right is Live Avatar at the exact same moment. It's still crisp, still clear, and perfectly consistent with the original. The difference is just night and day.
To really push the limits, the team ran this incredible stress test. They just let Live Avatar run for 10,000 seconds. That's almost 3 hours straight. And the result? At 10 seconds, at 1,000 seconds, and even at the 10,000 second mark, the output was still clear and consistent. This basically proves the system has, for all intents and purposes, infinite stamina.
So, we've seen the tech, we've seen the proof. What does this all actually mean for us? Well, this isn't just another cool research paper. Live Avatar closes that massive gap between a sci-fi concept and a practical, real-world tool that people can actually use right now.
And the applications this unlocks are just incredible. I mean, think about it. Digital assistants that you can have a truly natural conversation with. Video game characters that can react and talk to you on the fly, not just spit out pre-scripted lines. Or what about personalized AI tutors that can adapt to exactly how you learn? This is the next huge leap forward for everything from live streaming and communication to virtual reality.
You know, the research team themselves summed it up perfectly. They wrote that Live Avatar lays a solid foundation for the practical deployment of next-generation interactive digital humans. In other words, they didn't just make a small improvement, they solved the core problems that have now turned what was once science fiction into a practical reality.
And that leaves us with a really fascinating thought to end on. For the very first time, we have the technology to bring any picture, any character, any historical figure to life and have a real conversation with them. So the question is no longer if we can do it, the question is, who would you want to talk to?